Hello student, myself Dr. Swati Tavele, working in Sandeep Institute of Pharmaceutical Sciences, will start course Pharmaceutical Engineering in that very first unit 1, that is on flow of fluids. So at the end of this course, student, you will able to understand, to know the various unit operation used in pharmaceutical industries, than to perform various processes involved in pharmaceutical manufacturing processes, as well as to carry out the various tests to prevent the environmental pollution. So these are the course content. So course divided into unit 1 to unit 5. So unit 1 will give the emphasis on the flow of fluids as well as the size reduction and the size separation, whereas the unit 2, it gives the emphasis on, or it includes, the heat transfer, evaporation and distillation. Unit 3 highlights on drying, then mixing, which is utilized in the pharmaceutical industry for the manufacture of the formulation, whereas unit 4 make us aware about what do you mean by filtration, and again it will tell about the centrifugation process which is to be used in the manufacturing industry. Then unit 5, it gives the totally emphasis about the various material used in the pharmaceutical industry or pharmaceutical plant, where the various constructive material which is to be get utilized and how the corrosions you can be get prevented. So this is the in brief about the course. Now next, course structure. First, course code for this course BP304T. Name of the course Pharmaceutical Engineering. Now total number of hours assigned for this course 45. Total credit point assigned as 04, that is the 4 hours credit assigned. Next, the scheme for the internal assessment as well as the end semester examination. The internal assessment, it includes the continuous mode and the sessional examination. 2 sessional exams shall be conducted for each theory as per the schedule fixed by the colleges. The scheme of question paper for the theory is given as below. So this is out of 30 marks. Then the next one is what here, the question paper pattern for the sessional exam is given as shown in this table. Next, end semester exam. The end semester exam, again marks allotted 75 and total duration 3 hours. So total 100 marks assigned for this course, including internal assessment as well as the end semester examination. Now question paper pattern for end semester theory examination given in this table. Now some important formulas, you have to just keep it in mind for this flow of fluid. As we already learned about, the pressure is equal to force upon area. So in this, most probably will come across the term force. So force is equal to what? That pressure into area you have to consider. Then kinetic energy. The kinetic energy term again we already studied, and this kinetic energy, this is related to what here? Whenever the energy in a body, it occurs due to its motion, and it is given as what? U square divided by 2g. Then pressure energy is given by, that is totally related to pressure, then density and acceleration due to gravity. Then potential energy, this is nothing but the energy in a position that is in a body due to its position. Okay, so here in Bernoulli's theorem we will see that is whenever the fluid it flows from the pipe at the position A and B, the potential energy is taken as XA and XB at the point A and point B respectively. So let us start here from the first, that is fluid flow. So fluid flow, what do you mean by fluid? Initially you should know. So when we applied the any shearing stress to the fluid, it continuously deform, means it flows. As everybody know, three states of matter: solid, liquid and the gases. Here the fluids are the subset of phases of matter and it includes the liquid and the gas. Now what do you mean by fluid flow? The fluid flow defined as what? The flow of substance that do not permanently resist the distortion. Now permanently resist the distortion. Distortion means what here? That is alternation of the original shape. Permanent shape not necessary. So fluid shows the change in shape. Whereas when we consider the third state of matter, that is the solid, solid does not shows the change in shape. So that is the difference in between the fluid flow as well as what here, whenever the solid we will consider. Now the fluid flow, it divided into the two types. The first one is what? The fluid statistics, and the second one is what? Fluid dynamics. So let us see, or let us start from fluid statistics. So fluid statistics, student, keep it in mind, when the fluid is at the rest in equilibrium, this will be considered as a statistics. Okay, the fluid statics. Next one is what here? The nature of pressure. It will be exerted on this block. Now here it's shown as what? One of the block containing what? The water. Okay, and the variation of pressure at the different layers. So pressure differences between the layers of liquid calculated. So again observe this diagram here. In this diagram we will consider here, that is column of liquid with the two opening, okay, which are provided at the wall of vessel at the different height. So rate of flow through this opening, these are to be get differ just because of pressure it will be get exerted at the different height. And here the pressure it is given as what? H1 and H2. So pressure difference, that is from surface to point 1 given as H1, as well as the pressure which is given from surface to at point 2 as the H2, and difference in between these two, it is given as what? Delta H. Okay, so consider here, this is the stationary column which is having the pressure as the PS. So pressure PS, it is acting on the surface of fluid, and this column is maintained at the constant pressure by applying this pressure. Now we have to initially consider the force which is to be acting below and above the point 1. Okay, and this is to be evaluated with the help of this formula, that is nothing but force acting on liquid at point 1 is equal to force on the surface plus the force exerted by the liquid above point 1. So as we already see, whenever the term force is there, to write force is equal to pressure into the area. So pressure at point 1 into area is equal to pressure on surface into area. Now force exerted by the liquid above point 1. This is given by the equation mass into acceleration. Why the mass here? Because water it is there and water has some density. So that's why the mass has taken. Okay. So this is the last equation which is to be obtained with the help of this diagrammatic presentation. Then next we'll solve this equation. So P1S is equal to P2S. P1S is equal to this P2S plus volume into density into acceleration. Now P2S volume, it is replaced by height into area, again same into density into acceleration. So again similar, solve this equation. P1S is equal to P2S. Then here the height it is given as what? The H1. Then here area as the S, density as the rho, and G is the acceleration. Now since the surface area is same, okay, so P1 is equal to PS plus H1 rho into G. Now pressure which is acting on point 2, it has written as what? That is P2 is equal to again PS, then height as the H2 into again rho into G. Now difference in pressure it is obtained by the formula P2 minus P1. P2 minus P1, it is nothing but delta P. Then this both the equation it has to be written, and after that you will get this equation. G term it will get common. So G in bracket PS plus H2P bracket complete minus PS again H1P, then common term G. Then delta P is equal to PS H2P minus, solve this bracket, minus PS minus H1P into G. Then at last what the equation you will get? Delta P is equal to delta H rho into G. So this is the last equation which is to be get obtained in fluid statics. Then next one is what? Fluid dynamics. So fluid dynamics, it is deals with what? The study of fluids in motion. It is not in rest. Okay. Now why it is necessary to study the fluid dynamics? This study it is to be necessary, or it will be helpful for the liquid, gels, ointment, which will change their flow behavior whenever it is exposed to the different stress condition. Okay, and this will be very helpful in various pharmaceutical industry whenever we have to go for the mixing of the various fluid, and after mixing it flows through the pipe and then it will be goes into the container. Okay, so in that case we have to study the flow of fluid, whether it is to be viscous or whether it is to be just thinny. So fluid properties, again it is very necessary to study at this stage. Now you might be get aware with this viscosity. Okay, that is viscosity, it indicates what? Resistance to flow. It have some viscosity, that is just it will causes the resistance to flow. So that terminology again it will be helpful in this case. Now let us start from the Reynold experiment. So this Reynold experiment, where here you will be helpful this term, that is the viscous liquid as well as what? The non-viscous liquid. Now in this Reynold experiment here, consider here the glass tube which is connected to the reservoir. Okay, and this rate of flow of water, it is to be totally get adjusted with the help of ball. A reservoir of the colored solution, the reservoir of the colored solution connected to one end of this reservoir is connected to the one end of the glass tube. With the help of the nozzle, the colored solution is introduced into the nozzle in the form of what? Fine stream. So laminar flow is, or the viscous flow, it is nothing but here the fluid particles moves in a layer or laminar with one layer sliding over the other. Whereas when velocity of water is increased, when the velocity of the water is get increases here, the threads of colored water disappear and entire mass, and here the entire mass of water get uniformly colored. Okay, the flow of the fluid it is considered as what? Turbulent flow. So this is nothing but the difference in between the laminar flow as well as the turbulent flow. Now in this case again you have to study the change over of a flow from viscous to that of the turbulent is the critical factor, and the next term it is related to this critical factor is the critical velocity. So what do you mean by critical velocity? The average velocity of any fluid at which the viscous flow change into the turbulent flow, that is called as what? Critical velocity. So this is nothing but here about the Reynolds experiment. So these are again the diagrammatic presentation where it shows the turbulent flow than the laminar flow. Now importance, okay, so identification of this type of flow, why it is important. This is helpful in manufacture of dosage form, handling of the drug for the administration. And here when we study the flow of fluid through a pipe, it can be viscous or turbulent, it can be determined by Reynolds number, and this Reynolds number have no unit. So let us start here. What do you mean by Reynolds number? So Reynolds number, it is given as shown in the diagrammatic presentation here. These are the four factors. What are these? The first one, viscosity of the fluid, density of liquid, average velocity, and the diameter of pipe. These are combined in one way, and that is called as what here? The Reynolds number. And this Reynolds number, it is given with the help of this equation, that is inertial force divided by viscous force. So inertial forces, these are due to mass and the velocity of the fluid particle try to diffuse the fluid particles, whereas the viscous force, if the frictional force due to the viscosity of fluid which makes the motion of the fluid in a parallel. So that is nothing but here your Reynolds number. Next one, at low velocity the inertial forces are less when compared to the frictional forces, and this will result in what? The viscous in nature of that fluid. So other hand, whenever the inertial forces are predominant, okay, the fluid layer break up due to increase in velocity, and hence we will observe that turbulent flow. Now when the Reynolds number is less than 2000, the flow it is called as what? The laminar flow. Whereas when the Reynolds number greater than 4000, the fluid the flow it is called as what? Turbulent flow. Whereas when the Reynolds number lies in between 2000 to 4000, the flow change between from laminar to turbulent. So this is all about what? The Reynolds number. So in nutshell, you have to just keep it in mind. The Reynolds numbers depends on four factors. It is nothing but inertial forces divided by your viscous forces, okay. So whenever the inertial forces are there, okay, these are less when compared to the frictional forces, you will observe what here? The viscous nature of the fluid. Whereas here, whenever the inertial forces are predominant, the fluid layers, this will get break up, and this causes due to increase in velocity, and you will observe the turbulent flow. As well as the values, you have to just keep it in mind, that is 2000, 4000, less than 2000 laminar, more than 4000 turbulent, and in between if it is there, that is between laminar to the turbulent flow. Next, what is the applications of Reynolds number? So Reynolds number, it is used to predict the nature of flow, that is whether it is the viscous one, laminar one, or the turbulent one. That the Stokes law equation, it is modified to include the Reynolds number to study the rate of sedimentation. Now rate of sedimentation observed in what? That is in suspension. Now next thing is what here? Whenever we try to plot the velocity against the distance from the wall, okay, the following conclusion you can be drawn, that is flow of fluid in the middle of pipe is faster than the fluid near to the wall, okay. The velocity of fluid approaches zero as the pipe wall is approached. So at the actual surface of pipe wall, the velocity of fluid is zero. So from this one, what we can say, that here the flow of fluid is more in the middle of pipe than the wall of the pipe. Next, let us see the next term, that is manometers. Now you might be studied in 11 and 12th standard various types of manometer. So let us brush up the things. That is, manometers are the device. This is used for what? Measuring of the pressure difference. And this manometer, it is classified as what? Simple manometer, inclined manometer, as well as the differential manometer. Next one, let us start from the simple manometer. So this is the commonly used manometer, and as shown in the diagrammatic presentation, it consists of what? The glass U-shaped tube, which is to be get filled with the liquid A, which is having the density rho A, and above A arm these are filled with what? The liquid B with density as the rho B. Now student, keep it in mind while selecting both the liquids, these are immiscible with each other and the interference can be easily observed. Now if two pressure difference applied on the two arms, the meniscus of one liquid, it will be higher than the other. Okay, so let us apply, or let us see here, if we apply the pressure P1, that is in Pascal, at the point 1 as well as what? At the point 5. Okay, so P1 at the point 1 as well as P2 at the point 5. Now pressure at point 2, it can be written as what? P1 plus M plus R. This M plus R, these are nothing but distance. Okay, distance from 3 to 5. Rho B, this is nothing but the density of liquid, and the G is the acceleration here. So why we have taken rho B? Because liquid B, these are acting on what? That is at point 2. So the equation that is generated at point 2, P1 plus M plus R rho B into G. Now next, since the point 2 and 3, these are at the same height, the pressure at 3 can be written as the same, that is P1 plus M plus R rho B into G. Now pressure at point 4, it can be written as P2 plus G, acceleration due to gravity, M, that is nothing but distance, and again rho B. Why rho B? Because again liquid B. Or here it can be written as P1, okay, P1 plus rho B plus M plus R G minus, here to just make it minus, that is nothing but here the rho A R into G. So two way you can write this equation. Now both the equation should be equal, so that's why P2 plus GM PB, this is equal to P1 plus PB M plus RG minus rho A R into G. Now solve this equation. P1 minus P2, this is nothing but delta P. Okay, after that you will get this equation GM rho B minus rho B, again in bracket, that is M plus R rho plus rho A R G. Then after that again solve this whole equation, you will get here delta P is equal to GM rho B minus GM rho B minus, solve this equation, that R rho B G plus R rho A, and at last you will get the equation delta P is equal to R in bracket rho A minus rho B, common term rho, that is R it has taken, then R rho A minus rho B, that is into G. So this is the final equation for the simple manometer. Now let us see the next one, that is differential manometer. Now this manometer, these are most probably utilized for measurement of the small pressure difference. It is also called as what here? Two fluid U-tube manometer. And again it contains the two immiscible liquids, that is A and B, which is having nearly same density, and the U-tube contains the enlarged chambers on both the limb. Now using the simple principle of simple manometer, the pressure differences, it can be written, that is delta P is equal to P1 minus P is equal to R rho C minus rho A into G. So this is the final equation obtained for the differential manometer. And next, the inclined manometer. Now inclined manometer, so inclined manometer, again this is related to what here? Some position, it is to be in an inclined manner, but this manometer, it is not to be useful widely. But let us see, that is in short about that or the equation. So this will be most probably utilized in drafts and very low differential, primarily in air and the gas installation. So this manometer, this is to be arranged with the indicating table as inclined. Okay, so this will be provided some an extending scale, and the pressure difference, this is to be given with the help of the equation P1 minus P2 G into R rho A minus rho B and sine alpha. Just because of the inclined position here, the sine alpha, it has to be taken into the consideration, but it is not widely used in a pharmaceutical industry, or it is not having wide applications. Next, that very important even as per your examination also, that is Bernoulli's theorem. So what is the Bernoulli's theorem? So Bernoulli's theorem, this is nothing but here, when the principle of law of energy is applied to the flow of fluids, the resulting equation which is to be obtained, it is called as what? Bernoulli's theorem. So while considering this Bernoulli's theorem, you have to consider here the pump working under the isothermal condition between the point A and B. And this Bernoulli's theorem, it states that in steady state, the total energy per unit mass, it consists of what? Pressure, kinetic and potential energy, these are constant. Now in very first we already seen some formulas, okay, that is for the kinetic energy, pressure energy as well as the potential energy. So just remind the same formula, kinetic energy is equal to U square divided by 2G. Pressure energy, this is related to what? Pressure, density and the acceleration. So PA divided by rho A into G. So at point A, 1 kilogram of the liquid is assumed to be entered at this point, and the pressure energy which is given in joule can be written as again the same PA divided by G into rho A. So PA, it is nothing but pressure at point A. G is the acceleration due to gravity. Then rho A, this is the density of liquid. Then potential energy of the body. This is nothing but here the energy possessed by the body by the virtue of its position. So their position of the X, it is nothing but XA, some height, okay, that from that height the liquid is flowing. So potential energy has a XA. Then kinetic energy of the body. This is defined as what? Energy possessed by the body by virtue of its motion. We already seen the energy possessed because of its motion, and it is given as what? Kinetic energy is equal to US square divided by 2G. As you already know, 1/2 mv square. This equation most probably we are utilizing. Okay. Now total energy at point A is nothing but here the total sum of pressure energy plus potential energy plus kinetic energy. So at point A, you will get this three equation, okay, that is combination of these three. PA divided by G rho A plus XA plus UA square divided by 2G. Then according to the Bernoulli's theorem, the total energy at point A is constant. So let us write this equation is equal to constant. Then after the system it will be reaches the steady state, that is whenever 1 kilogram of liquid enters at point A, 1 kilogram of liquid leaves at point B. So total energy of point B, again it is calculated, simply change here instead of A as a B. Okay, so PB divided by G rho B plus XB plus UB square divided by 2G. So input is equal to output. So let us equilibrate this equation. Okay, so theoretically here all the kinds of energy which will be involved in fluid flow, it should be get accounted. So pump has certain amount of energy, and the energy added by the pump as nothing but here W. So next thing is what here, that is as the energy is added, so during the transport some energy again is converted into the heat due to the frictional forces. So that loss of the energy is given by the F. So at last equation you will get, that is loss of energy minus F, and the energy is added as the plus W. So simply add minus F plus W and let us write the same equation, and this equation it is called as what? The Bernoulli's equation. Then next, what is the application? It is used in measurement of rate of fluid flow. It is applied in the working of centrifugal force. In this kinetic energy it is converted into the pressure. So this is all about what? The Bernoulli's theorem. So in Bernoulli's theorem you have to just keep it in mind, the total sum of what? The potential energy, pressure energy and the kinetic energy, and after that you have to add, that is energy which is to be added by the pump as the W, and some loss in energy just because of converted to heat due to frictional forces, that is nothing but here minus F. So this is all about the Bernoulli's theorem. Now these are some of the references that are used for this lecture. Okay, so in nutshell here student, what you can say, that is various flow of fluids, that is fluid statistic and dynamics, then why it is necessary to study the flow of fluids, then what are the various manometers and the Bernoulli's theorem that we have seen in this lecture. Hope you understand everything. Thank you student.